Hello everyone. Um, Today's tutorial is going to be about model comparison and interpretability. Like we have, these are not completely new concepts for you. Like we have touched on those already. Like you have, I suppose you have already knowledge about model evaluations and interpretability. We have touched on this before in the previous weeks as well. So this is not completely new, but we're just going to be brushing on over them. And then if you have any questions, we can go through those as well. So just as a let's say a recap of some sort, we can talk about model evaluation. So comparisons. So the title is model comparisons, not model evaluation. But okay, in comparing models, in the case you're considering, or just in general, is about like how to select the right model, basically, and that's entail multiple considerations to begin with. First is like I'm just going to say this as is in words, but like they are not really on the slides, but yeah, can like we can add them later, or just like consider them in your head as for the moment. So the consideration when you choose a model to begin with is that like of course you're going to choose a model that is suitable for the task on hand. So we're talking about LLMs, large language models. We're not really, so this applies, what I'm going to say here applies to machine learning models generally, but we're considering the case of large language models. So in that case, like when you're choosing models to begin with, candidate models, you'll be considering like the task on hand you're going to use it for. Like for your case is like text classification, or it's an NLP, a natural language process of named entity identification or recognition. So this is a text classification task. So you have to consider the models that work for this, and then you're going to be considering things like computational powers, or like resources you have at hand. What else? And you're going to be coming up with candidates for those, like depending on these cases. And then this is a case or where like evaluation comes in. When you're going to be using them, you have a list of candidates. You can evaluate them and compare their performance. And from there, you can basically, this is a case of comparison. So this evaluation is one of the steps or one of the consideration you do when you're comparing your models, right? Okay, so well, evaluations. So it's like in the case at hand, again, it's an NLP task. We're considering NLP task. So the evaluation is a comprehensive process to assess the performance of the language model for the particular task we wanted to use. And why is evaluation important? Like these substance, like you already know, it's like or when applied to LLMs in particular, this you're going to be of course like comparing the models, so comparing the performance of multiple models, but also for each, you're also like seeing if there are inaccuracies or problems with the model, or the training of the model, or the fine-tuning of the model in your case, basically. You can identify the strengths and or the limitations, and then basically you can plan and work on improving the performance. So yeah, so this is like general things. So generally, when you're evaluating an LLM, you're thinking about like you're trying to evaluate the training and basically comparing the models again. That's what I've said, like which models are the best. And then generally, this is like in general, completely generic. So when you are writing, like let's say, consider like you are evaluating an LLM and writing a paper basically on it. Basically, you are thinking about like the whole field of LLMs and their capabilities. So like of course this LLM field is very big, so but like consider in the case of Amharic language, if you're evaluating the models, understanding the capability of models related to Amharic, for the Amharic language. Okay, so generally there are multiple ways to evaluate LLMs. So LLMs as language models, because they do NLPs, uh, natural language processes, in the evaluation are not always straightforward. And this is like, I'm mentioning this just for like knowledge in general, knowledge in general. So how they are evaluated. So is because that's the tasks that LLMs are used for. There are like, for example, the 6 classifications, the case at hand you have for this challenge, which is just a classification case. And basically, you can think of it like when you think of a classification, like when you evaluate a model for classification, you are like measuring metrics like accuracy and recall and precision and F1, maybe F1 score. Like these are like simple metrics you can think of. And basically, you can prepare a data set and just run your model and measure the scores on those. And basically, this is what is called automated benchmarking. So you just run the whole thing automatically, which is fine in this case. But in some of the cases of for natural language models or LLMs are used for like text generation, question answering, um, uh, what else? Like there are summarization and translation, all of this stuff that's not as easily evaluated. So there are not an easily defined metric, and not an easily computed score. So there are other ways to evaluate LLMs. One of them is using humans, basically humans as like as judges, or using LLMs as judges as well. So if you are using LLM to judge an LLM, so I'm not expanding on those, but basically, of course, like using a human. So this is just like preparing a data set. Sorry. What you have on this slide is that you're saying automated benchmarking. You need a data set, basically a test data set and a matrix, basically. So that's what you need. For human judges and or model judges, I'm not expanding on those, but like course humans, like basically they can use LLM and it can be something like really systematic, provided guidelines for them how to judge the output of the model for a particular task, let's say it's a question answering. LLM, using an LLM, it will do the same. So you'll use an LLM to generate the output and then use an LLM to look at this output and judge it, whether it's accurate, is it whatever, like it is for text generation, or like let's say for question answering, is it the correct answer? So yeah, so like which is like, of course, using an LLM is cheaper than using a human. Like it's also like there are human biases that can arise in when you are using humans, while LLMs also have their own set of biases as well. So there are things that to consider when using a voice. So, but this is just generally for the case at hand. We're using basically automated benchmarking, or like basically just what is like a normal evaluation for machine learning models. So yeah, so this is for evaluation generally. So do you have any questions about this so far? Okay. Any question?
No, you lost. That's why.
Okay. Um. All right. Okay. So let's see if okay. Let me just show you like maybe demo on this. So okay, so 1 second. Before moving on to the interpretability, um, let's okay. So I see like you see like this code. All right. So this code like basically it's the goal of this code is to evaluate a model, a couple of models for name entity recognition. So this is the task that is evaluated for. And here, what we're going to be using, so is a data set, like, so this is just from, um, uh, this is a data set for name entity recognition for in French. So this is the case I'm using here. So the data set is from Hugging Face. And you can see that there are like this in the data set, there are text, okay, in one column, and then token, so it's tokenized. So there's like, let me see if I can. So the okay, let's maybe just like open the is like the data set card. So this is the data set card on Hugging Face. And you can see that for each text, you will get like a set of tokens, right? And then for each, there is like either a label or not, depending. So basically, there are a set of labels. Of course, they are not like the same as your case, but like there are like labels for each span, each so there are like a set of like names or whatever this like a person or a common noun, and then like a different tags basically. And okay, so what we do here, back. So I have this data set. So this is my test data set. I'm not going to be like, I'm not fine tuning my model here. I'm just going to test the model. I'm going to evaluate the model of this. And so like maybe you can do like a set of cleaning here in this function. The goal of this function is to give me like for each text, it will give me like a set of tags for each token. So just like a list. So for each token, it's going to be giving me just the label for each. It's either like whatever tag or O is outside. So it's nothing. It's basically a non label basically. And then with this, I will have like my data set ready, and I can basically calculate the difference. Okay, so the code, so like first, of course, like I will load a prediction from my model, and then format it so that I will have the same format as in the in like in the output of the target of my data set. And then I will evaluate basically the yeah, so the accuracy, can calculate the accuracy and or other scores I want to have. So I haven't run this code here in my case, but like I'm getting this just code from GitHub. Because they were testing models of OpenAI and several models, and I'm just getting it from GitHub repo here, so can just see here the result of the running the code. So they calculate the precision, recall, and F1 scores for each label individually, and yeah, so and of course, in the end, you can compare like different models with this. So I know I'm not saying anything like really, I'm not explaining this code in details, but like this is a general idea. So here in this case, they're writing all the functions to do this, how to do these evaluations, but you have tools as well, like for example, like get Hugging Face has an evaluator uh, class. Evaluation is an evaluation library basically. And let me see, like I have this an open. So let me share. Hugging Face has one, like, and you can find also like OpenAI has another like an evaluation. See. So Hugging Face has also data sets that you can use. Of course, that in your case is you're using your own data set, so you're not using that. But like basically, you can also use different metrics they have defined. And yeah, so you can see like the code in their case. What's it? Yeah, here. So you can see how the code is run. So you have the data set and they evaluate from evaluator. So this is like the evaluator from evaluate, which is a Hugging Face library. And they are using the pipeline for from transformer. This is like they're going to be using loading the data set, loading the evaluator for token classification, which is like the token classification is the case of name entity recognition. And then basically they'll be just running the like the evaluator on the model with the data, and then using this metric. And this metric has sequence evaluation, so it has these different scores. So overall F1, overall accuracy, and you can see like the cards for this metric also on Hugging Face, and basically can get the result in this case. So it's like it really doesn't take much. It's very very modularized, but depends on like of course here we're using like you can use the pipelines from transformer pipelines to also run your test, or you can just emulate how it is done, like whatever is best in your case. Okay, so I don't know if like I hope this was helpful in some way. Do you have any questions? Any questions at all? Okay, so let's say you don't have any questions, so let's move on to the next part. And so modern interpretability, this is something like we kind of discussed in a sense before. Like I personally, I think one of my tutorials before we talked about interpretations of the machine learning models predictions. So in details or more interpretive just in few words, it means explaining the reasoning behind the result of the model. So if we can a model interpretability is the ability to explain to a person like this is how the model predicted this. Okay, just like given this input they got that output, explains the reasoning of the model. There is all in terminology like they can there is interpretability and explainability. So explainability is like explaining the like algorithm internal steps, so it's like just knowing the details of the algorithm, and how it is designed, how it goes from input to output. But just explaining the reasoning is what interpretability is. You can put it together as like the same, like used interchangeably to with both basically. Anyway, so thinking about it, like I think we have discussed it before, like having a black box model against a white box model is like when a black box is when you don't know what is the like internal working of the model, so you don't really understand. You have the input and the output, but you don't really understand how the model arrived at this result from this output. If you know a white box is when you know, like you understand the steps in details, um, which feature or or at least understand like which features were like important, what are the correlation, what is the causations, like what caused this result to be this, even if it's you don't understand like the intricate steps in the middle. Like explaining it, let me just okay, so why interpretability is important. So think about the use cases of LLMs or AI in general, but like LLMs in our case, so with this wide ranging uses as that's happening right now, large language models are being used in so many domains, in so many for so many uses, and just to be able to trust the results that you get, that it is dependable, we need to understand how the AI models arrived at this decision to begin with. In cases of like our training the models, fine-tuning the models, and testing them, evaluating them, we want to understand, we want to debug when we find inaccuracies in the predictions or biases in the predictions. We want to be able to debug, but if we don't understand how the model works, we cannot really go back and see which process has to be like corrected, basically from these problems. There are like interpretation is important for um, satisfying some regulations in like legal regulations, basically. We get required to explain how how when you're using AI system, you have to explain how you arrived at these decisions. So humans need to understand how the AI model arrived at the decisions to be able to satisfy this. And this is the last point is very important, is knowledge transfer, understanding how models arrive at the decision and the underpinning how they're working, like contributed to the like the accuracy or their resulting decisions, helps us to basically can inform us to build newer models or develop the model further, basically. So thinking again back at like yeah, so this is like the general like importance of this. So for interpretability, there are two types. There are global interpretability and local. So global is just understanding the whole model, how it works. It's an overall structure. And this like models that are simple, like machine learning models that are simple enough, can be globally interpretable. It's a hard word. So like linear regression, if you remember, like decision trees are globally interpretable because they are inner working are simple and intuitive for us to think about. So it's easy to understand just how they arrived at a particular decision. Complex models are, on the other hand, are non-interpretable. So these are like deep neural networks, ensemble models, and of course language models, which are like as a type of deep neural networks. Basically, they're very big and they're very complicated. So those are also not globally interpretable in general. So local interpretability, on the other hand, is understanding like how the model are made a specific decision for a specific instance in the data. And this is like a simpler way. So instead, like you don't need to understand how the whole model arrives at the part of all of its inner working, or like its how it arrives its decisions in general, but you need to understand it for a particular instance. And you need to, like for this, like understanding the weight of different features, or like the causal relationship between the input and the output. These are or the correlations. These are important. These are enough to just understand like having local interpretability. So there are tools, as we discussed before, that help us with this to arrive at this, basically. And so just to discuss them in more details. So for complex models, interpretation, you can have apply interpretation methods to understand like how the models arrived at their output. And there are like tools that we mentioned before, like Lime and CHAP. So Lime like works on explaining the prediction, a particular prediction for a single prediction at a time. So it does that by creating a simpler model for mimic the behavior for the complex model for a specific prediction, and basically uses feature attribution to see like the different like the weight or the influence of a particular feature, particular input on the output of the model. SHAP, on the other hand, is like we discussed before, is like it's a game theory approach. It considers all combination of all features, and how they apply predictions applies not all for a one particular prediction, but for like an overall for all like a sample. And it gives like a Shapley value, which as a result of applying it is give us a value that for each feature, signifying the contribution for that particular feature to the output. And then it's like its model basically agnostic. It's work for any system. It provides global explanation. It doesn't depend on the particular model. but because it's calculates like or like consider all possible combinations, is very computationally expensive. Like as you, I think you have experienced before when you tried it before, it can take a long time to run or can read a lot of resources to run. So it's yeah, so it comes with that. um there are other like partial and individual dependence plots. These consider the effects of uh, like effects of the features or input on the output, basically. And so it's a plot to help visualize the relationship between the input and output. And like so the difference between like they are similar to each other, but the individual conditional expectation plots, this consider only like like it's specific feature instead of like set of features basically on the output. And they can be complementary to each other. So like this is just the general approaches to calculating the interpretations, or like yeah, so getting the model interpretation, understanding like how the model um, arrives at its output. Okay, so this is a generic thing. So in any questions? No questions. Everything is super clear. Everything like you know how you're going to be doing this, at least like of a concept um, at the concept level. Mm, okay, no questions. Everything okay. Um, Give me a minute. There. Okay. Okay, if there are really no questions, I think we can end this tutorial here. But like, I'm really not convinced that. Um, so maybe like, let's see, like, so let me just ask you how, like, okay. Like, how is it going for you with the challenge so far? Like, which like task are you at the moment? Have you like really arrived at task? This is task 3 and 4, task 4 and 5 actually. So maybe it's a bit later. So like, which like maybe you can just share on the chat box, or like maybe open your mic and say like which where are you on the challenge. Like, which task are you on at the moment? There are no wrong answers here, so you can just like let me know. I'm just trying to see if the lack of questions is means that you really understand. Okay. Or is it because I just haven't like arrived at this stage yet? So some people at class 2. Okay. That also is the labeling. Okay. So because this is day 3, it's really still like you still have time, of course. And I suppose like once you start, of course you can evaluate the model even before you fine tune it. So you don't really need to like, I mean, not, it's not required really, but you can just try it, evaluate the model and running this task. Okay, so so let me just not take more time from you. I'll try to like um I don't know if it's like with this no interactions is not really okay. All right, so I'm not reading. So okay, I have more answers. So some people ask also 1. I'm downloading the video data 2. I think documents and image data should be downloaded. You're scraping the data. Still on task 1. Okay. Okay, so yeah, like of course, like the scrubbing task is actually not as easy. So like I understand that you are still like at the area stage. Good, good. So how is it? At least 5 channels, but the tutor sent us only 1 channel. Is that true? So okay, so there are 2 questions. One about the interim report, and the other one is about the channels. Okay. So as always, the interim submission, you can just, the requirement is like, so it's a PDF. You're required to submit a PDF, 1 to 2 pages, and assessing basically the progress of your project, provide a data summary, and the data preparation and labeling steps, like as far as you have gotten. So like what's required is a PDF, so it can be like an article, it can be an article format, like a report format. It can also be a PPT, so like a presentation as well, like but just submitted as a PDF. So there are no requirement to have a presentation for this case. So yeah, always pay attention to what is required in the submission, the deliverable, the submission on the challenge document. As for the channels, okay. So okay, so the question like all right, so is this okay? You have a data selected from like data that is scrapped already corrected from okay, so you have the set, have you checked the data folder? Like you have there like the channel names basically that you can look at. So I am not sure. Um, there is data from a particular channel, but like you have other channels that you can scrap basically. So I don't know, maybe yeah. So yeah, as Khaled has said, there are 22 channels in the spreadsheet, and basically you need to scrap. Uh, this is like task one. Basically, you have to okay, get the data yourself from the channel. Okay, so if you have question about how to do this, please ask. We are here to basically help you with that. Okay, so who was asking the question? Samara. So Abraham is saying, unable to get the code from my phone. Which code? I'm not sure. This is this answer to. We are missing some of the quiz. Okay. So any other no questions like related to the tutorial at hand. So let's continue this. Suppose on Slack, because like what is your next oh, you still have time actually. So what is your next session? Yeah, but so are there other questions besides like the problem with scrapping the data? Like anything else? Okay. So great. Yeah. So thanks for like interacting. Okay. Interact at the end. And thank you for attending. And if you have any questions, of course, like when you arrive at this task, you might have more questions. So we can discuss later on as well. So yeah, I would say let's end this tutorial here. And I will